Welcome to the deep dive. Today, we're really getting into the weeds on something super practical, super important if you're working in the cloud. That's Fortinet Cloud Security Essentials.
Yeah, essentials is the right word.
We're using some, well, think of them as practical scenarios, kind of like the problems you'd see for cloud security certs, specifically around Fortinet in AWS and Azure. But this isn't a test prep session, really. We're using these scenarios more as a launch pad.
Exactly. A launch pad to understand the core ideas behind securing these cloud environments. Our goal today, let's get through the jargon, yeah? Pull out the really key nuggets about deploying, managing FortiGate, other Fortinet stuff in AWS and Azure. Think of it like a shortcut. Get you up to speed on some really critical cloud security challenges.
Absolutely. So whether you're maybe prepping for a meeting or just exploring this field or honestly just curious, this deep dive should give you some of those aha moments, how these security tools actually plug into AWS and Azure.
Ready to jump in?
Let's do it. Okay, first up, cloud network routing. Let's picture this. You're building, say, a central security hub. You've got a FortiGate VM in AWS, and you're using a transit gateway, a TGW, right, as the backbone. So the big question is, how do you make absolutely sure all the traffic from your different spoke networks actually goes through that FortiGate for inspection?
Okay, yeah, this is fundamental.
Yeah.
The absolute key is a specific configuration in your TGW route table. You need a default route. That's 0.0.0.00.
The classic default route.
Right. And critically, it needs to point directly, specifically, to the network interface attachment of your FortiGate VM. It's not about pointing to an internet gateway or, other VPCs. It has to be the FortiGate's attachment. That's what centralizes the inspection.
Okay.
And the why behind this? Well, it's pretty important. That simple default route, it forces everything. All the traffic between your VPCs, your spokes, and any traffic going out to the internet from those spokes has to go through the FortiGate first.
Right. So it truly becomes that central checkpoint.
Exactly. It makes the FortiGate a proper security gateway. It's not just sitting there. It's actively inspecting all that cross-VPC and outbound flow. Makes auditing simpler, too.
Makes sense. Centralized control. Okay, so that's steering traffic in AWS with TGW. What about Azure? Things are always a bit different there. Let's say you've got a FortiGate VM in Azure, again, for centralized inspection. How does it, magically know about all the dynamic stuff, like Azure Network Security Groups, NSGs, or maybe VNet tags, stuff that changes? How does it build smart policies around that?
Yeah, that's not magic, thankfully. There's a specific feature you need. It's called the Fabric Connector for Azure SDN. You have to have that configured on the FortiGate.
Fabric Connector for Azure SDN.
And what that connector does, essentially, is act as the bridge. It links your FortiGate directly to the Azure API. So the FortiGate can then pull real-time information about your Azure network. It sees the NSGs, it sees the tags, it understands the Azure environment natively. And because it has that real-time info, you can build security policies that are actually dynamic. They can use those tags, those NSGs, as criteria. So if you spin up a new VM and tag it web server, a policy can automatically apply. No manual updates needed. It's a huge win for, agility. Security keeps pace.
That automatic adaptation is huge in the cloud. Okay, let's talk high availability, HA. Always a big topic. Specifically for FortiGate VMs in AWS. Now, you might think, okay, standard HA clustering, right? Like you do on-prem.
Yeah, that's the natural instinct.
But there are some AWS limitations, networking quirks that make FortiGate's built-in clustering tricky. So how do you get automated failover without that native clustering?
Right. This is a really common scenario and solution. The standard, robust way to do this in AWS is actually using two standalone FortiGate VMs.
Standalone. Okay, not clustered.
Correct. And you pair them with an AWS Lambda function. The Lambda function's job is to handle Elastic IP, or EIP, remapping.
Lambda comes to the rescue.
Pretty much. Because FortiGate's native HA, things like FGCP, they rely on mechanisms like virtual MAC addresses and gratuitous ARP, which don't work quite the same way in the AWS network fabric.
Right, AWS networking is different.
Exactly. So the Lambda function acts as the orchestrator. It constantly monitors the health of your primary FortiGate, maybe using API calls, maybe checking routes. If it detects a failure on the primary, boom. The Lambda function automatically, programmatically, moves that public-facing Elastic IP address from the failed instance over to the standby instance.
And the traffic just follows the EIP.
Precisely. Seamless redirection, or, well, near seamless. Minimal downtime. It's a clever cloud-native workaround for that HA challenge.
That is pretty clever. But, does using Lambda like that add its own layer of complexity? Something else to manage and monitor, right?
That's a fair question. Yes, you do have another component, the Lambda function, that needs managing, monitoring, maybe updating,
Hmm.
but you weigh that against the benefit. You get automated failover, which is often critical using
Hmm.
native AWS services. The complexity is sort of contained within that serverless function, which is arguably better than trying to force an on-prem HA model into the cloud where it doesn't quite fit.
Good point. Trade-offs, as always. Okay, staying with cloud best practices. Infrastructure as code.iac. Crucial for consistency, repeatability. So if you're deploying FortiGate VMs in Azure, along with all the network stuff, VNets, subnets, route tables, using IaC, what's the recommended native Azure tool these days?
The go-to native tool now, that would be Azure Bicep.
Bicep. Okay, I've heard more and more about that.
Yeah, it's definitely gained a lot of traction. It's essentially a newer, more readable domain-specific language, or DSL, that compiles down to the older JSON ARM templates.
Easier than wrestling with giant JSON files.
Oh, much easier. The syntax is cleaner, more intuitive. It makes defining complex setups, like a FortiGate, with all its dependencies, significantly simpler. And because it's simpler and clearer, your deployments become more consistent, easier to repeat, easier to manage across different environments, dev, staging, prod. It really helps with that whole scaling and baseline security posture thing.
Consistency through code. Makes perfect sense. All right, let's switch gears slightly. Troubleshooting time. Imagine this. You've got a FortiGate in AWS. It's Fabric Connector, the thing we talked about for dynamic objects. It's failing. Can't connect to the AWS API. What's the first thing you check? The most likely culprit.
The Fabric Connector failing to connect to the API, 9 times out of 10, maybe even more.
Really?
It's permissions.
IAM permissions.
Exactly. The IAM role that's assigned to the EC2 instance running the FortiGate VM, it's probably missing the necessary permissions to make those specific AWS API calls. See, the FortiGate needs that IAM role to securely authenticate and then ask AWS things like, hey, what instances are tagged production? Or
Yeah.
what are the details of this VPC? If the permissions aren't granted in the IAM policy attached to that role, AWS just says, nope, access denied.
So the connector just fails.
Right. It can't establish the connection or it can't get the data it needs. It's a fundamental security thing, least privilege and all that. But it's so often the root cause when that connector has issues. Always check the IAM role first.
Good practical advice. Check IAM first. Okay, let's pivot to web application security. How do you position a FortiWeb VM that's Fortinet's Web Application Firewall, or WAFAF, to actually inspect traffic going to an Azure app service? Where does it sit in the network path?
Right. Protecting app services with a wave.
Yeah.
The recommended and really the most direct way is to put a FortiWeb VM in the same virtual network, the same VNet as your app service.
Same VNet. Okay.
And then the crucial step is you need to control the routing. You use an Azure user-defined route, the UDR.
Okay.
You apply this UDR to the subnet that the app service is integrated with. And that UDR basically says, hey, any traffic coming into this subnet destined for the app service needs to go to the FortiWeb VM's private IP address first.
Ah, so you force the traffic detour through the way?
Exactly.
Okay.
The traffic hits the FortiWeb, gets inspected for things like SQL injection, cross-site scripting, all the usual OWASP top 10 stuff.
Yeah.
If it's clean, the FortiWeb then forwards it on to the actual app service. It provides that critical layer of defense right before the application itself.
Makes sense. Intercept and inspect. All right, logs. Can't forget logs. Absolutely vital, right? Compliance, troubleshooting, everything. So a FortiGate VM in AWS, it needs to send its logs somewhere central, scalable, durable, preferably native AWS for long-term storage. What's the FortiGate feature you configure for that?
For that scenario, scalable, long-term, native AWS storage, the best practice is to configure logging to an AWS S3 bucket.
S3. Okay.
And you typically do this using, again, a Fabric connector. There's often a specific logging setting within the FortiGate configuration that lets you point logs towards S3.
And why S3 specifically?
Well, S3 is just purpose-built for this kind of thing. It's extremely durable, highly available, and incredibly cost-effective for storing huge volumes of data for long periods. Think compliance requirements, keeping logs for years sometimes.
Right, retention policies.
Exactly. Plus, once the logs are in S3, you can easily integrate with other AWS services for analysis, like Athena for querying, or maybe feed them into a SIEM. It becomes a really powerful, centralized log repository in the cloud.
Yeah, S3 is definitely the workhorse for that.
Okay.
Back to routing, but in Azure this time. Azure Virtual WAN. It's a popular hub-and-spoke solution for large enterprises. If you integrate a FortiGate VM into an Azure Virtual WAN setup, what's the main reason you'd enable BGP peering on the FortiGate? What does that achieve?
BGP with virtual WAN. The primary purpose there is dynamic routing. It's all about exchanging routes automatically between the FortiGate and the virtual LAN hub.
Dynamic routing, so avoiding manual static routes.
Precisely. Imagine you have dozens, maybe hundreds of spoke VNets connected to your virtual LAN hub, plus maybe connections back to on-premises sites via ExpressRoute or VPN. If you enable BGP between the FortiGate, which often sits in a security VNet connected to the hub, and the virtual WAN hub, the FortiGate automatically learns all the routes to all those spokes and on-prem networks from the hub.
So it knows where everything is without you telling it explicitly.
Exactly. And conversely, it can advertise routes back to the hub if needed. It ensures traffic flows correctly through the FortiGate for inspection without you managing a massive, complex set of static routes. It's all about automation and scalability for routing.
Less manual config, less chance of error. Makes sense. Okay, new frontier.containers. Kubernetes is everywhere. So task you secure an Amazon EKS cluster, Kubernetes on AWS. You want depth visibility, real policy control, right down to the pod and service level. What Fortinet tool gives you that?
For that level of deep visibility inside the Kubernetes cluster, you're looking at FortiCWP. That's cloud workload protection.
FortiCWP. Okay, not just the FortiGate.
Right. Well, the FortiGate provides network-level security around the cluster. FortiCWP is different. It's purpose-built for cloud workloads, including containers and Kubernetes. It integrates directly with the Kubernetes API server and often involves deploying agents or sensors within the cluster nodes, or as daemon sets.
So it's inside the cluster itself.
Exactly. That gives it visibility into pod-to-pod communication, running processes within containers, vulnerabilities in container images, compliance checks against benchmarks like CIS. It offers things like runtime protection, detecting anomalous behavior in the container, which is something a network firewall just can't see. It's a specialized tool for that specific container security challenge.
That's a really important distinction. Network versus workload protection. Okay, final scenario. Centralized management. You're using FortiManager to manage a fleet of 40 VMs, maybe spread across different AWS regions. One specific FortiGate just won't connect to FortiManager. It keeps failing. What's the absolute single most common, maybe simplest reason for that failure?
Oh, the classic FortiGate won't talk to FortiManager problem.
Yeah.
You check the network paths, the security groups, firewalls.
Yeah, the complex stuff.
And then, 9 times out of 10, it turns out to be the most fundamental thing. The FortiManager's IP address simply hasn't been configured on the FortiGate itself.
You mean in the FortiGate's own settings?
Exactly. In the FortiGate central management configuration, you have to explicitly tell it, this is your FortiManager, here's its IP address. If that line is missing, or if the IP address is wrong, the FortiGate doesn't even know who to try and connect to. It's like trying to make a phone call without dialing the number.
Huh. It's always the simple thing sometimes.
It really is. So fundamental, but so easily overlooked during setup or troubleshooting. Always double-check that central management IP setting on the FortiGate itself.
So for everyone listening, you should now have a much clearer picture of how these Fortinet tools actually work in AWS and Azure, tackling specific security needs. And that leads to maybe a final thought to leave you with. As these cloud platforms, AWS, Azure, they keep evolving, right? New services, new architectures popping up constantly. How do you think these spiralized security tools, like Fortinet's, will need to keep adapting? What's the next step in integration to keep pace, not just with new services, but also with, well, the new threats that inevitably come along?
That's the million-dollar question, isn't it? Constant evolution.
Something to definitely chew on. Thanks for diving deep with us today. Keep learning, keep exploring that cloud security landscape. We'll catch you on the next deep dive.